So from Pascal's triangle, there's what they call the Sierpinski's triangle, which you can get all of these kind of triangles from. Now, the beauty of Pascal's triangle is that when you have an expansion to make, like you have something to expand, let's say x plus a to the power of 5. This row, this is our row of 5. This is row 0. This is row 1, row 2, row 3, row 4, and row 5. So these are all the coefficients of your expansion. That is, if I have raised to the power of 5, if I have something like this and I want to expand, your final answer must have 1, 5, 10, 10, 5, and 1 as the coefficients of all the terms. If I'm to expand to the power of 6, 1, 6, 15, 20, 15, 6, and 1 must appear as coefficients of that expansion. In fact, they are the only coefficients of the expansion. So now, having something like x plus a to the power of 5. First of all, let me give you another hint on the beauty of Pascal's triangle. One beauty of Pascal's triangle is that these Pascal's triangles are all multiples of 11. Beginning from here, this is 11. Sorry, they are not just multiples, they are 11 to some powers. So 11 raised to the power of 0 is what? 1. 11 raised to the power of 0 is 1. Anything raised to the power of 0 is 1. 11 raised to the power of 1 is 11, which is 1 and 1. 11 raised to the power of 2 is 121, which is 1, 2, 1. Do the same thing for 11 raised to the power of 3. You get 1, 3, 3, 1. You can convert that using your calculator. Do the same thing for 11 raised to the power of 4. You get 1, 4, 6, 4, 1 as your answer of 11 raised to the power of 4. Are you understanding what I'm saying? So, as long as you keep increasing the powers of 11, you will keep getting triangles. Although there is a part in this triangle where you would have to do some manipulations to get it exactly how it is appearing on this triangle. Can somebody check 11 raised to the power of 7 for me, or raised to the power of 6? 1, 5, 6. So 1. So first of all, 11 raised to the power of 6, we are dealing with row 6. This is row 6, this is row 0, row 1, row 2, row 3, row 4, row 5, and row 6. And then this is row 7. First of all, looking at this, our rows on the Pascal triangle, if you want to get it to appear this way, 11 raised to the power of 6 is appearing. First of all, you write your 1. You write your 7. Now, at this point, which of them? Okay, we are dealing with this. 11 raised to the power of 6 is the 6th row. This is the 6th row. So we have our 1, we have our 6. Now, if I'm to continue this, I will write 5, which is the tens. The units. Units are the first, any number that is standing alone, like any number that is just one figure is a unit. So the unit of 15 is 5. Now I will carry 1, just like when you are doing addition. I will carry 1 and add to 20. I have 21. I carry 2. I write 1, carry 2. We wrote 1, we carry 2. Now that 2 add it to 15, you have 17, carry 1. That 1 add it to 6, you have 7. And then that 1 that we added to 6, you can drop it down now to get 1. So you can see that we used this row to get back to 11 raised to the power of 6. If you do the same thing for 11 raised to the power of 7, what you need to do is 11 raised to the power of 7 without pressing your calculator and telling me any answer. This is our 7th row. So I will write 1. I have 7 here. 7. I have 21, but I'll write 1. Carry 2. That 2 I will add it to 35. I have 7, carry 3. We're here, right? So that 3 that we carry, you add it to 35. We have 8, carry 3. That 3 we add it to 21, we have 24, carry 2, right? That 2 add it to 7, you have 9, and then you can drop the 1. Check 11 raised to the power of 7, you should get this answer. So Pascal's triangle is just 11 to some exponents. Many things are in this Pascal's triangle. Now it is left for you to go and find out something from this Pascal's triangle. Mind you, the only thing you might do in maths might be that you brought out something from Pascal's triangle. This here, these skills we're talking about. So far in mathematics, I think this is the only, on it, to be on the safer side, this is the only place I've heard of this name in mathematics as a whole. So you can go and find some other beautiful stuffs from this. So now we're saying if we have x plus a raised to the power of 5. Now when we want to expand this stuff, the first thing we need to know is we are dealing with combination. Are we all familiar with how to solve combination? Combination is giving n things, n number of things, and we have to choose r from that n number of things. That is, n choose r. In mathematics, it is written this way. I think we have n, and we want to choose r things from n. Now, to find n choose r out of n, this is n factorial divided by n minus r into bracket factorial and then r factorial. If I decide to arrange it anyhow, if I decide to use r factorial first and put n minus r factorial second. So each of them, they are bounded together by multiplication sign. So for this combination we are dealing with, combination is telling us that we have n number of things and we are choosing r stuffs from n. We have, let's assume all of us in this class are about 15, and I want to choose 5 people out of 15. That is 15 choose 5, right? Right? 15 choose 5 is equal to, permit me to rub this off. 15 choose 5 is equal to 15 factorial all over 15 minus 5 into bracket factorial 5 factorial. Mind you, this combination could be written as, some people are saying this is not what they taught us or this is not what they showed us. It's the same thing. This could be written as 15 combination 5. But just to show that you are a bad guy, you are a mathematician, just to show your teacher that you know passing, I do not advise you. You can just write it this way. So first of all, you have 15 stops, you are choosing 5 out of that 15. Your 15 is your n, 15 factorial, which is n factorial. Your r is 5. So you have 15 minus 5 factorial and then 5 factorial. You all understand to this point? Now factorial is telling us that having a 10, we are multiplying this 10 by the 10 immediately below it, by the 10 immediately below this 10, by the 10 immediately below this other 10. That is when we have 5 factorial. 5 factorial is equal to all the counting numbers below 5. And then we multiply them by themselves and multiply them by 5. That is 5 times 4 times 3 times 2 times 1. Are you following? There's supposed to be a 0 factorial here. First of all, factorial is dealing with numbers that are counting numbers or natural numbers. Counting numbers are natural numbers. Natural numbers are numbers we use in counting. The number of people in this class now, we use natural numbers to count them. Now 0 factorial is always 1. Okay, let's say 0 factorial. Let's move small. We have 1 factorial, 2 factorial, 3 factorial, 4 factorial. Now let's verify why 0 factorial is 1. People might be asking why 0 factorial 1. First of all, in mathematics, the thing that virtually every mathematician is running away from is having 0 at the bottom. Are you following? You don't want to have 0 as the denominator of your fraction. You are trying to avoid 5 over 0. Because it means how many times can you find 0 in 5? If I ask everybody, how many times can you find 0 in 5? Somebody says it's not possible. It's actually very... It's possible to find 0 in 5, definitely, but you don't know how many zeros you can find in 5. This means how many times will you add 0 to itself to get 5? Infinite. It might not even be infinite, it's undefined. Because as long as you keep adding 0 by 0, 0 plus 0, 0 plus 0, 0 plus 0, you can never get to 5. Are we following? Yes. And mind you, never look at 0 as something that is empty. So, under this factorial, this is telling us that we are multiplying 5 times 4 times 3 times 2 times 1 times 0 factorial. 0 factorial is 1. That's why at times they like to skip it. But let's explain why 0 factorial is 1. Because I think I've seen a question that they just said 0 factorial is 1. Now 4 factorial is dealing with 4 times 3 times 2 times 1, right? And this is, let me write this here, this is equal to 4 times 3 is 12. 12 times 2 is 24. 24 times 1 is still 24. To get to 3 factorial, we will say 24 divided by 4. This 4 here. 24 divided by 4 is what? 6. To get 2 factorial, we say 6, or let's do it the normal way it is. This gives us 3 times 2 times 1, which is equals to 6. 2 factorial is 2 times 1, which is equals to 2. 1 factorial is 1. And 0 factorial is what we are trying to verify here. So 24 divided by 4 gives you 6, right? 6 divided by this 3 you have here, divided by 3 gives you 2, right? 2 divided by this 2 we have here gives you 1, right? And then 1 divided by this 1 we have here gives you 1. So 0 factorial is 1. So should in case you find it in your question, just know that 0 factorial is 1 using this kind of proof we are dealing with. Now, I don't think it's not possible to find the answer of a negative factorial. The thing is, when they taught us in our 100 level, I was like, why can't you find the negative number factorial? So I wrote one rubbish, because I was feeling myself. I wrote one rubbish and I went to show somebody, and it was like, the people the mathematicians that came up with this stuff that it can never be negative number, know what they are saying. Like those people have gone through the series of proving to show that. Like me, I'm just on the level, my brain is not yet as wide as theirs. My brain is actually as wide as theirs. So this 15 choose 5 or 15 combination of 5 is equals to 15 times 14 times 13 times 12 times 11 times 10 factorial. We all know this is still the same thing as writing it to 1, right? 10 factorial is 10 times 9 times 8. So this thing is still the same thing as writing times 9 times 8 times 7 times 6 times 5 till we get to 1. The reason I stopped in 10 is because 15 minus 5 is what? 10. So we have 10 factorial and then 5 factorial. I stopped at 10 because 10 factorial is the same thing as 10 factorial here, right? I mean, 10 factorial is, so this cancels this. We are left with 5 factorial. 5 factorial is 5 times 4 times 3 times 2 times 1. 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. So we have 15 times 14 times 13 times 12 times 11. Somebody with a calculator, please, what's your answer? Just check 15 times 14 times 13 times 12 times 11. What's your answer for that? I get, okay. I'll just clean this bottom part of the jollof rice. Yep. Yes? Why did I stop at 10? Okay, it's because 15 minus 5 will give me 10. I decided to I didn't stop at 10, I stopped at 10 factorial. Because I could decide to say 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. But all this can be short-handed or written in a short form as 10 factorial. You agree with that? So to avoid these plenty stuff, because it's very cost to buy marker, I'll end at 10 factorial so that I can cancel out. That's the reason. So if we are going to deal with smaller parts of this, I'm just trying to explain if we have 15 people in this class and we have to choose 5 people. Now, choosing 5 people from what's the answer here?
25740.
25740, right?
I've not divided this.
You haven't divided it?
It's 360.
Right, like this. Okay, 36 0.
360.
The way you guys call it up fast now. If I was an officer of mathematics, I would carry you guys to court. So this is 360,360. Any Igbo person here shout hallelujah. So we have 360,360. There's another zero.
There's no other zero.
So the only thing is just to find it out. So you can use your calculator to get this. Any calculator that has That calculator can
That's
help
not
us.
the final answer.
This
That's
calculator.
just the result for the given.
This calculator doesn't have
Divide
combination.
300.
Let me see your calculator. Okay, so for combination, look at the division sign here. On top it, there is a shift button which says NCR, right? Which is the same thing as this. Please let's reduce the noise. The noise is increasing. So to find something like 15 combination 5, first of all press 15. Press 15 if you have this type of calculator. I think the other one also has it. Then press 15, press shift, divide, press your division sign. Have you pressed it?
Yes.
I'm sure you should be showing 15C like this.
Yes.
And then you can press 5. What's your answer? The answer is 3003. So 15 combination 5 is 3003. So where did you get this answer? 3,000. Divided by 100. Yes. I expected the final answer. So just if you want to find a combination of stuff, just press the number. If you have 5 combination 2, press 5, press shift and press your division button to show C like this, and then you press 2. You get the answer for 5 combination 2. Now, so we explained that this is how to get 15 combination 5 using our calculator, which gave us 3003. Now, since we have 3003, this means that if we have 15 people in this class and we are to combine only 5, the number of combination I can have from those 15 people, that is, if I'm picking 5, let's say I pick this lady, this young man, that lady, and that guy. 5. I'll now decide to pick this lady, this guy. I will not choose that guy again. I will choose another person. That is, if we are to pick 5, we are to combine 5 people from 15 people. The different combination we have, even if it's just one person that is different from this other group, the different combination we have is 3003. So, going back to what our Pascal triangle is trying to tell us is that we are having coefficient of expansion. So x plus a, first of all, x is increasing, or let's write x plus a to the power of 5. This is equals to, now let's go to our 5th row. This is our first row, our second row, our third row, our fourth row, our 5th row, right? Now we take each of all these, we write 1, this gives us 5, this is 10, this is 10, this is 5, and then we have